Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening, children. Good evening, children.
Good evening, ma'am.
Good
Good
evening.
evening.
Good evening. My screen is visible, right?
Yes, ma'am.
Yes, ma'am.
Question number 11, 12, 13 and 14. You can understand using the working. Question number 11, we have discussed till question number 10. 11, 13 and 14. You should be able to understand with the help of the working. I'll be sharing that material, children, or I don't know if I've already shared. I'll just check and do the needful. Now read example 4, children. Two circular flower beds have been shown on two sides of the square lawn ABCD of side 56 meters. Okay, so ABCD is a square lawn, square garden. ABCD is a square lawn, a square garden of side 56 meters. Okay, two circular flower beds. So they're talking about this one, this portion which looks blue. They're talking about this and this one. Two circular flower beds. Somebody's mic is enabled. Please disable your mic. Kindly disable your mic. So the circular flower beds are these portions. These which look blue, the shaded region. Two circular. Circular means of a circle, a part of a circle. See, like when we say integral means of integers. When we say integral values, meaning of integers. Circular flower beds, so of a circle, a part of a circle, circular flower beds. So two circular flower beds have been shown on the two sides of a square lawn. So on the sides AB and CD, you can see two circular square lawns. So sorry, two circular flower beds. This portion, I'm showing you the portions here. A, B, C, D is a square garden of side 56 meters. That's one thing. This is one circular flower bed and this is the other circular flower bed. These are the two circular flower beds. They're a part of a circle. You don't see the complete circle here, but they're a part of a circle. This region is a part of a circle. This region is also a part of a circle. Circular flower beds. Integral of integers. Circular, part of a circle. If the center of each circular flower bed. So yeah, so when it's given that this portion which looks blue, this portion and this portion, it's given that they are circular flower beds. That means they're a part of a circle. This region is a part of a circle. This region is a part of a circle. So immediately the next question, what is the center of that circle? We don't see the circle, but which is the center? That's what is given here. If the center of each circular flower bed, if the center of each circular flower bed is the point of intersection O of the diagonals of the square lawn. Okay, so that means the diagonals AC and BD, we can see they meet at O. O has two relations, with one with respect to the square, the other with respect to the circle. Now for the square, O is the point of intersection of the two diagonals. For the square, O is the point of intersection of the two diagonals. And for the circle, O is the center of the circle. O is the center of the circle. That means with this as center, radius is not known. We only know the center. We have to find the radius. With this as center and that specific radius, when you draw a circle, this one will be a part of that circle. This one will be a part of that circle. See here with this as center, with this one as center, and the numerical value of radius not known. When with this as center, when we draw a circle, this region will be a part of that circle. So that means this one, this arc is a part of that circle, right? So from the center to B and A are the points on the arc. A and B are the 2 points on that arc. Clearly OA and OB are the radii of that circle. I'll repeat the same thing with respect to this one. So since it's given that O is the center of the circular flower beds, O is the center. That means with O as center and some radius, when a circle is drawn, so a circle is drawn like this, a circle is drawn like this, a circle is drawn. This region is a part of that circle. This region is a part of that circle. This region is a part of that circle. So clearly, since we know that O is a center of that circle, and the points C and D lie on the arc, lie on the circumference of the circular flower bed. C and D lie on the circumference. So from the center to any point of the circumference is the radius. So clearly OC, OD are the radii of this circular flower bed. We'll see the information again, children. We'll see the information again. We are given a square lawn. A, B, C, D is a square lawn. Side of the square lawn, 56 meters. Side of the square lawn, 56 meters. Now, these blue regions are the parts of a circle. These two blue regions are portions of a circle. The center of the circle being O. The center of the circle being O. OA and OB. Now for the square, what do you need? For the square, we just need the side. If you know the side of the square, you can answer any question related to a square. For the square ABCD, if it's enough if you know the side of the square, 56 meters. So you're good to go. Area you can find, perimeter, whatever for the square you can find because you know the side of the square. Now for the circle, what do you need? Radius. Only if you know the radius of the circle, you can answer anything related to a circle. So we just have one missing information. We do not know the radius. OA, OB, OC, OD, they are the radii. We do not know the value of the radius. If you find the value of the radius, you can answer any question related to this figure. That's how we understand the question. So what are the figures here? Square and some circular regions. Circular flower beds. Now what do you need for a square? Side. We know it. So you're good to go with the square. Any question related to the square you can answer. What about for the circular portions? We need the radius. That's not known, but we know the center. We don't know the radius, but we know the center. Oh, that is enough. We can somehow find the radius. So you need to first find the radius of the circular flower beds. Once you find the radius, any question can be answered because you know the side of the square, you know the radius of the circle. Any question can be answered. Now, so if the center of each circular flower bed is the point of intersection O, this is the center. Okay, of the diagonals of the square lawn, find the sum of the, what is the question? Find the sum, meaning you have to add what and what. Find the sum of the areas of the lawn and the flower beds. Find the sum, meaning you have to add, and you have to add what? Add the areas of the lawn. That is, you have to add the area of the lawn and area of the flower beds. You have to add the area of the lawn, area of the square lawn, and you will have to also, you have to add the area of the square lawn and the area of the flower beds. You'll have to find the total area. In other words, you'll have to find the area of this entire figure here. because this one is the lawn. A, B, C, D is the lawn, and these are the flower beds. So you should find the sum of the areas of the lawn and the flower bed. That means this full area, whatever you see here, this complete area you'll have to find. So you're going to work this answer, children. I'm just going to tell you how the answer goes. So we understood that we have to find the radius of the circle. And we know that in a square, the diagonals bisect each other at right angles. In a square, the diagonals bisect each other at right angles. So diagonals bisect each other, meaning they cut each other equally. AC, diagonal AC and diagonal BD, they bisect each other. That means O is the midpoint of AC, O is also the midpoint of BD. O is the midpoint of AC, that is OA is equal to OC. Similarly, O is the midpoint of BD, OB is equal to OD, because the diagonals bisect each other. Now, when you take up and they also bisect at right angles, children. This one is 90 degrees here. Angle AOB is 90 degrees. They bisect at right angles. Angle AOB is 90. Angle BOC is 90. Angle COD is 90. Angle AOD is 90. All these four angles. All these angles around O are 90 degrees. In a square. In a square, the diagonals bisect at right angles. All right, so now what we're going to do is we're going to find the radius of the circle. How? We know that BCD is a right triangle. BCD is a right triangle because it's a square. No, so this one is 90 degrees. This one is 90 degrees. So option 1 is you can use Pythagoras theorem. You know BC is 56. You know CD is also 56 because all sides are equal. This is a right angle because it's a square. It's a right angle. So in triangle BCD, by Pythagoras theorem, 56 square plus 56 square is equal to BD square. So like that you can work and find the length of BD. Whatever you get for BD divided by 2 will be the length of BO. Whatever you get for BD, whatever is the value of BD divided by 2 will be the length of BO or OB or OD also. That's how we find the radius of the circle. Or you can use the formula root 2a. Root 2a, the length of the diagonal of a square. The length of the diagonal of a square is given by the expression root 2a. So BD is equal to root 2a. That means root 2 into 56. So 56 root 2. The length of the diagonal is 56 root 2 divided by 2. 28 root 2. 28 root 2 is the radius of the circle. Is this part understood, children?
Yes.
To find, so see, we understood that for the square we have the side, meaning we know the length of the side of the square. We do not know the radius. So we take up the triangle BCD, any right triangle. BCD is the right triangle. Take up the right triangle BCD, use Pythagoras theorem and find BD. Or you can also use the formula root 2a. Diagonal is equal to root 2a and get the length of BD. Divide by 2 to find the radius. Divide by 2 to find the radius. OB is the radius, which will be 28 root 2. Now you know the radius of the circle. How do we find? Tell me, how do you find the area of the triangle AOB, children? How do you find the area of the triangle AOB?
Ma'am, half into radius.
Pi r square, ma'am.
Half?
Half into radius into radius.
Yeah, it's a right triangle, correct? This one is a right triangle. This one is a right triangle. AOB. This one is a right triangle. So area of this triangle is equal to half base into height. Half into base AO into height BO. or as Srinivasan said, half radius into radius, because this is 90 degrees. This angle is 90 degrees. So half base into height, will be the area of this triangle. And since this angle is 90 degrees, this is the center of the circle, and this angle is 90 degrees. This region, this entire region AOB, see here, AOB, and this circular portion, this entire thing is the quadrant. Is a quadrant. This full thing is a quadrant. See, from here to here is a quadrant. Why is it a quadrant? Because this is a center. This is the center of the circle. Here the angle is 90 degrees because we know by the property of a square, this is 90 degrees, and this is the radius. This is the radius, and you can see the arc here. So in the sector, why is it a sector? Because and an arc. So this full thing is a sector. This full thing is a sector, and the sector is a quadrant because this angle is 90 degrees. This angle is 90 degrees. It's a sector because see, a radius, arc. So it's a sector. And in the sector, the angle is 90 degrees by the property. In a square, diagonals bisect at right angles. This is 90. So there's nothing but a quadrant then. A sector whose angle is 90 degrees is a quadrant. So find the area of the quadrant or sector using 90 by 316 to pi r square. Find the area of the quadrant or the sector. Subtract the area of the triangle. Area of the triangle is half base into height. Subtract the area of the triangle to get the area of this blue region. And whatever you get here is the same here also. So supposing you get 50 here, this is also 50. So the total area of the flower beds will be 100. Then area of the square is easy, no? Side into side, 56 into 56. Yeah, I want all of you to work it like this. Please work, all of you. Area of the square ABCD is equal to, write down, area of square ABCD is equal to 56 into 56. After finding the area of the square 56 into 56, find the length of BD. Please follow my instructions so that it's easy to discuss. Find the area of the square ABCD. Next, find the length of BD, either using the formula or by using Pythagoras theorem. Okay, you have found the area of the square and the length of the diagonal BD. Now divide that by 2. BO is equal to BD by 2. BO is equal to BD by 2. 56 root 2 by 2. 28 root 2 meters. 28 root 2 meters is the radius of the circular flower beds. I'm not repeating, children, because I'm very slow. I am telling you very slowly. I'm giving you time to write, so don't ask me to repeat anything. One is to find the area of the square ABCD. 56 into 156. 3136 meter square. 2. Find BD. Answer 56 root 2. 3. Find BO. 56 root 2 by 2. 28 root 2 meters. Now next, after that, find the area of the quadrant. You can just take a point, you can just mark a point like say E here, and you can say area of the quadrant AOBE. This is the quadrant. This is a quadrant is a sector. A quadrant is a sector whose sector angle is 90 degrees. So this is sector. Find the area of the sector. 90 by 360 into pi r square, where r is 28 root 2. Find that. So after finding the area of the sector or quadrant, (90 by 360 into pi r square, 22 by 7 into 28 root 2 into 28 root 2. What's the answer, children? What's the area of the quadrant?
1132.
1000?
132.
1132. All right. Now you got the area of the quadrant. Find the area of the triangle. Find the area of the triangle AOB. It's a right triangle. It's a right triangle. In a square, the diagonals bisect at right angles. So this is 90 degrees. Half base into height. AO into OB. Half into AO into OB. Half into 28 root 2 into 28 root 2. Now, area of quadrant minus area of triangle will give you the area of the circular flower bed. We're doing it like this because in case they ask you to find the area of the circular flower bed separately, then also you should know how to do it. We'll also do this in another way. In this approach, we are finding the areas of the square and the flower beds separately. In this approach, we are finding the area of the circular flower bed separately and the square separately, and then adding both. So in case you're asked to find the area of the circular flower bed also, you will know how to do. So area of the sector minus the area of the triangle will give you the area of the circular flower bed. Double it, multiply by 2, so you will get this one also. Area of both the circular flower beds. Now to that add the, so now you found the area of the 2 circular flower beds. Have that answer separately. Find the, you already found the area of square ABCD. Add both to answer this question. Find the sum of the areas of the lawn and the flower beds. Sum meaning you have to add both. Add the area of the lawn and the flower beds. In this approach, we are finding the areas of the flower beds separately and the square separately. You can share your picture on WhatsApp, children. Yes, see, as always, Srinivasan is the first to send. I like your discipline, Srinivasan. That will take you a long way. Very good.
Ma'am, I made a mistake, ma'am, but I don't know where.
Yeah, that's why I know that. I just saw that, but I'm just talking about your discipline, the way you presented your answer. Yes, I'm waiting for more answers, children. It's 1232. Area of the quadrant. It's 1232. You've written 1132.
Okay, ma'am.
Yeah. (22) into 56 is correct. That product, by mistake, you've written 1132.
Yes, ma'am.
Yeah. Only one student has responded. If I need to clarify something, please ask me. Okay, class, so what is the measure of angle BOC? What is the measure of angle BOC?
90 degrees.
Class? Yeah, thank you, Srinivasan. Let's just wake the others. Yes,
90 degrees.
angle BOC is 90 degrees. It's not given 90. How do we assume it's 90? What is that property of a square?
Ma'am, and square diagonals are bisect each other at 90 degrees, ma'am.
Yeah, they bisect each other. That means O is the midpoint of AC and BD at right angles. So all those four angles around O all measure 90 degrees. Okay. Is AO half of AC?
Yes, ma'am.
Is
Yes,
AO half of BD? Is AO half of BD?
Yes, ma'am.
Yes,
Why?
ma'am.
Yes, ma'am.
Why?
Ma'am, because
Diagonals are equal in a square.
Because diagonals are equal. Because AC is equal to BD. AC is equal to BD. So AO is half of AC, which also means AO is half of BD. Should I wait for you to complete, children? Is it over?
ma'am, 1 minute, ma'am.
Okay.
Hey, dude.
Okay, let's see the next approach. I'll just please make a note of all this. Step one is to find the area of the quadrant AOBE. I said mark a point on the circumference here, call it E. Step one, find area of AOBE. Write on this, children. AOBE. Find area of AOBE. Next, double that answer. Then you'll have to double it because whatever is the area here will be the same here also. Supposing you call this point F, you take a point F here. So the area of ODFC also will be the same as this one. So find the area of this quadrant. Find the area of this quadrant. The same will be the area here. So if you find this, just double it, you will get the area of this. Or okay, you found the area of this one. The same as the area here. All right. Now we are left with these two portions. This one is a right triangle. This one is a right triangle. Area of this one is half base into height. Half into base into height. Half 28 root 2 into 28 root 2. And the same will be the area here. And you know, the question is to find the area of the entire figure. The area of the square lawn and the flower beds. That means we'll have to find the area of the entire figure. So to find the area of this entire figure, we just need to find the area of this quadrant and find the area of this triangle, which is a right triangle. Find the area of this triangle, which is a right triangle. Area of the sector is equal to the area of this sector. Area of this triangle is equal to the area of this triangle. So supposing it is say 5 here, this is also 5. This is 2, this is also 2. So 5 plus 5 plus 2 plus 2 will be the total area. In the first approach, we found the area of the circular flower bed separately, square separately, and we found the sum. That is one way of doing it. Otherwise, you can find the area of this quadrant, find the area of this triangle. Area of this quadrant is equal to the area of this quadrant. Area of this triangle is equal to the area of this triangle. And see here, this is a right triangle, half base into height. It's a right triangle. And we know that the base and height are equal to 28 root 2 meters. That's it. So this is a simpler one. This is a simpler meaning it's a less time consuming approach. Yeah, do it this way also and see that you get the same answer in both the cases. Is it understood, children?
Yes, miss.
Yeah, what about the others?
Yes, ma'am.
All right. So find the area of the shaded region in this figure. Find the area of the shaded region. Given that ABCD is a square, ABCD is a square. ABCD is a square of side 14 centimeters. So how do you handle this? First, what are the plane figures involved? Obviously, the four circles are congruent circles. The four circles are congruent circles. They're identical circles. Only then they can touch each other like this. They can touch each other like this only if they're identical. Okay, so from the way the circles are placed, they touch each other. So the circles are identical circles. That means all the four circles have the same radius. So we have two plane figures, one square ABCD, side is given to you 14 centimeters. So what else you need? And we have four circles, all identical. So we need to find the radius of a circle. We need to find the radius of a circle. So once you find the radius of a circle, the area of the shaded region will be area of the square minus the area of the four circles. Area of the square. From the area of the square, take away the area of the four circles to get the area of the shaded region, the blue region. To find the area of the blue region. Now what is the radius of the square circle? What is the radius of the circle?
7, ma'am.
Please think again. Radius.
3.5.
3.5.
3.5. Radius is 3.5 because so from here to here, see, let's just take up the diameter. Let's just take up the diameter. See, from here to here diameter, from here to here diameter. So this diameter plus diameter is equal to 14. This diameter here plus this diameter here is equal to 14 because the side is 14. The side is 14. So this diameter plus this diameter is 14. So this diameter alone should be 7. 7 here and 7 here. So 14. So the diameter here is 7, which means the radius is 7 by 2. The diameter is 7, which means the radius is 7 by 2. So in circles, mostly, see, if at all you go wrong, it's mostly because we don't take the values of the value of the radius correctly. See, somehow we mistake the value of the diameter to be the radius. Something like this we go wrong. So be very careful. Diameter is 7. So the radius is 7 by 2. So find the area of one circle, multiply by 4 to get the area of the four circles. Find the area of the square, subtract the areas to find the area of the shaded region. What's the diameter of the semicircle? What's the value of the diameter of the semicircle?
Ten centimeters.
10 centimeters. What's the radius?
5.
5 centimeters. So look at this. Find the area of a semicircle. Find the area of one semicircle. Find the area of one semicircle. How? Pi r square by 2 or half of pi r square. Find the area of one semicircle. See here, one semicircle, this one. Find the area of one semicircle. Radius you know is 5 centimeters. Be careful in using the value of the radius. Radius 5 centimeters. And multiply that by 2. The area of one semicircle into 2 will give you the area of this semicircle and this semicircle together. Now, from the area of the square ABCD, if you subtract the area of these two semicircles, you will get the areas of regions 1 and 3. Let's do it again. Find area of square ABCD. Okay, 10 into 10, 100. Find area of semicircle with radius diameter. Find the area of the semicircle. Find the area of the semicircle with radius diameter. Okay, so half pi r square and r is 5. All right, finished. Then double it. Double it meaning when you double it, you will get the area of the semicircle with radius diameter and the area of the semicircle with BCS diameter. So you will get this area, this area, this area, and this one. Now from the area of the square, if you take away the area of these two semicircles, you will get the areas of regions 1 and 3. You will get the area of the regions 1 and 3. These white portions 1 and 3. Just imagine, no, from a square, if you take out the semicircle, if you cut a semicircle like this and another semicircle like this, you will be left with the areas of only 1 and 3. You have a piece of paper, ABCD, square. From that you cut a semicircular portion like this and another semicircular portion like this. You will be left with only these two portions, this 1 and 3. Now what you do, supposing 1 plus 3, supposing 1 plus 3 is say something like 20. Supposing, okay, it's 20. 1 plus 3 together is 20. Then 2 plus 4 is also 20. If 1 plus 3 is 20, then 2 plus 4 also will be 20. So 1 plus 3 is 20. So areas of 1, 2, 3 and 4 will be 20 into 2, 40. So now the area of the shaded region will be the area of the square minus 40. See, the square has two things in it. The square has some region which is shaded and some other region which is not shaded. What is the total area of the square? The total area of the square is the area of the shaded region and the unshaded region put together. So from the area of the square, if you take away the area of the unshaded region, you will get the area of the shaded region. From the area of the square, if you take away the area of the unshaded region, you will be left with the area of the shaded region. So the unshaded regions are 1, 2, 3 and 4, whose area is, for example, 40 centimeters square. So now from the area of the square ABCD, if you take away the area of the unshaded region, 40 centimeters square, you will get the area of the shaded region. So 100 minus 40, 60 centimeters square. Complete the working, children. Try it now. You can use the working you see here on the screen. Please try it now, children. Yes, if you're finished, please share the picture of your working. If you're not able to unmute and talk, and if you also do not have another device to capture a photo and send, whatever be the reason, at least use a chat here and let me know that you have finished working.
Ma'am?
Yes?
Ma'am, I have previous examples.
Yeah, 1 minute.
Example 4.
Yeah, sure. I'll go back to that. Let's just, have you finished this one?
No, ma'am.
Yeah, let's finish this and go back to that.
Yes, ma'am.
Yeah, sure. We'll go back to that one. And let me just wait for all of them to finish this.
Yes, ma'am.
Okay. Got it from Srinivasan. Thank you, Srinivasan, for responding. All right. Yes, Arna.
Ma'am, the previous one.
Yeah. Example 5, right?
4. Ma'am, here we can do like this area of square ABCD plus area of 2 semicircles.
No, they're not semicircles. They're not semicircles. These portions are not semicircles. This one is not a semicircle. Okay, fine. Let me answer that. If this is a semicircle, then the center should lie on. If this is a semicircle, then CD should be the diameter. And how do you know if CD is the diameter? The center should lie on CD.
Yes, ma'am.
If suppose if we feel this is if this is a semicircle, then CD should be the diameter. And okay, so maybe CD is the diameter. Then the center O should lie on CD. Then the center O should lie on the diameter CD. If this were the semicircle, then CD is the diameter. And if CD is the diameter, then the center should lie on the diameter CD. Well, it doesn't lie, it's away. It's here, which means CD is not a diameter, it's only a chord. CD is not a diameter, it's only a chord. And the chord subtends an angle of 90 degrees at the center. The chord subtends an angle of 90 degrees at the center. That was a good question, Arnam. That was a very good question. So I'm sure a few others also would have had the same doubt in their minds. So you helped me to, also hint on this one, talk about this one. Thank you, Arnav. Yeah. So clearly this is not a semicircle. Yeah. Moving on. Look at this. Please read the information given. It's a very simple one. I want the answer from your end. Answer meaning not the final answer. I just want the steps we need to go through to get the answer. Like, for example, find the area of the circle, next find the area of the triangle, do that, do this, just the procedure.
Ma'am, area of right triangle QPR.
No, it's not a right triangle. It's not a right triangle. Because it looks like a right triangle, we cannot assume it to be a right triangle. If at all you feel it's a right triangle, you must say why it is a right triangle. Let's start from there, yeah.
Area of triangle QPR.
All right, darling. Yeah, we have to find the area of the triangle QPR. But you were right. Your earlier statement was right. I just want you to tell me how it can be a right triangle.
One minute, ma'am.
Yeah. Yes, class. Ask yourself these questions. Circle. Do you know the radius of the circle? What are the plane figures involved here? So triangle and circle. So triangle, how can you find the area of the triangle? Do you have information to find the area of the triangle? Then for the circle.
Pythagoras theorem.
No, yeah, 1 minute. For a circle, do you know do you have the value of the radius? So if you have the radius of the circle, and if you can by any means find the area of the triangle, then yes, you can find the area of the shaded region. No, we are saying Pythagoras theorem, but how do you know it's a right triangle in the first place? Pythagoras theorem can be applied only in a right triangle.
Ma'am, angle of a semicircle.
Yeah,
Ma'am,
good.
is it angle of a semicircle?
Yeah, but I think you can be more clear on that. Yes, you've got it. You've recalled the correct theorem, but you can be more clear. Yeah, good. Priyadarshini, Priya and Manasa have shared your pictures. Good. Yes, Arnav, you're right.
Angle of a semicircle is 90 degrees, ma'am.
Angle in a semicircle. Yes, angle in a semicircle is a right angle. Very good, very good. Angle in a semicircle is a right angle. Standard 9, chapter circles. Chapter circles. Okay, so now QR is the diameter because the center O passes through QR. So QR is a diameter, which means this region is a semicircle. This is a semicircular region. This one is a semicircle. Angle in a semicircle is a right angle. How do we identify that? See here, P is a point on the circumference. P is a point on the circumference. RQ is the diameter. The diameter RQ, it makes an angle on the circumference at P. See here, join. See now we have the ends of the diameter Q and R. QR is a diameter. R is a point. R is a point on the semicircle here. Join R to P and Q to P. Join the ends of the diameter. Join the ends of the diameter to the point P. See, this portion is a semicircle. This one, strictly speaking, it's a semicircular region, this portion, because this one is a diameter. QR is a diameter. Now on this semicircle, we know that this is a semicircle. This is a semicircle. We know that this is a semicircle. On the semicircle, there is this point P. R to P. You can see the line segments from R to P and Q to P. That means the diameter makes this angle on the circumference at P. And the diameter always makes an angle of 90 degrees on the circumference. That's what is called angle in a semicircle is a right angle. Angle in a semicircle is a right angle. So this is a semicircle, this one. This angle in a semicircle is a right angle. So by the theorem, or you can also recall this. We know that the angle subtended by an arc at the center is double the angle subtended by the same arc at any point on the remaining part of the circle. You can go back to your 9th standard textbook and recall this theorem. After the class, just find your book and see this theorem on the chapter circles. So going by that theorem, this angle is 180 degrees. The angle at the center here is 180. So this will be 90. I haven't told you in detail, children. You have to go back to your books and recall it yourself. So this is 180 degrees according to that theorem. So the center here is 180. So this will be half of it, 90 degrees. All right. So you don't have nothing much you have to write. You just have to say angle in a semicircle is a right angle. That's it. And say therefore angle RPQ is equal to 90 degrees. How do you make out that this angle only is 90 degrees? So this is a semicircular region. This one. Point P is a point on the semicircle. The ends of the diameter RP, you can see the diameter line segment RP and QP. That is from the ends of the diameter we have line segments on the point P to the point P. This angle is a right angle. The diameter subtends. The diameter subtends an angle of 90 degrees. Always subtends an angle of 90 degrees at any point on the circumference. So this is 90. Now it's easy. Yes, what's the radius of the circle? How much is PQ?
24.
How much is PR?
24, ma'am. PR is 7.
7.
7 centimeters.
Yeah, how can you find the length of the line segment RQ, diameter RQ?
Ma'am, by using Pythagoras theorem.
Pythagoras theorem. So 576 plus
2.
49, 625. Square root of 625, 25. QR is equal to 25. Diameter is 25. What's the radius?
25 by 2.
25 by 2. Now see, you got the radius of the circle. And for the triangle, you can use the formula half base into height. Half base into height. Now what is it? Tell me the equation in words. How do we find the area of the shaded region? Tell me the equation in words. Area of what?
Area of semicircle minus
area of semicircle minus area of the triangle.
Very good. Area of the semicircle, not area of circle. Area of the semicircle. So half pi r square. half pi r square. Area of the semicircle minus the area of the triangle will give us the area of the shaded region. And for the circle, we know the radius. For the triangle, we have the base and height to find its area. That's it. Area of the semicircle minus the area of the triangle. So how do we go about the answer? We need to, the plane figures are circle and triangle. Circle, we don't know the radius. So first we have to find the radius. Without finding the radius, you cannot do anything. First, we need to find the radius. So we have to use this theorem, angle in a semicircle is a right angle. So the triangle, so this triangle is a right triangle. This triangle is a right triangle. We'll have to apply Pythagoras theorem and find QR. Half of QR, OQ is the radius or OR is the radius. So 25 by 2. So now we have the radius of the circle. And for the triangle, you know, this is the base and this is the height, or you can regard this as the base and this as the height. Half base and height will give the area of the triangle. So area of semicircle minus the area of the triangle will give us the area of the shaded region. Good. Now I want the answer for this one, children, this one. Like I want it in words. Like for the earlier one, we said area of the semicircle minus area of triangle. Who can tell me? Think and tell me.
Area of the triangle plus area of the major sector.
Very good, very good. Area of the triangle plus the area of the major sector. Very good. Area of the triangle plus area of the major sector. What kind of a triangle? Read the question. You can see the question above. So this is 12.22, children. 12.22. You can see the question here. 12.22. Please read this. Please read this. I have some questions to ask you. Read this. Yes. What is the major sector angle? What is the major sector angle?
60 degree.
200 degrees.
How much?
300 degrees.
300 degrees.
300.
Degrees.
300. What is the major sector angle? 300. Very good. Yeah, 300 degrees. The major sector angle, this angle. The major sector, this is the major sector. This is the major sector. Why is it a sector? See here, you can see it's bounded by two radii and an arc. So this is a major sector. The major sector angle is 300 degrees. It's 300 degrees. So how do we find the area of the major sector? What's the formula?
360 minus theta by 360 into.
Yeah. So the angle here is 300 by 360 into pi 22 by 7 into r square, 6 square. And how do we find the area of the triangle?
Root 3 by 4 side square, ma'am.
Root 3 by 4. Root 3 by 4 into side square. So root 3 by 4 into 12 into 12. That's it. That's all. Find the area of the triangle. Find the area of the major sector. Add both. Because it's an equilateral triangle, this angle is 60 degrees. So the major sector angle is 360 minus 60. This one is 60 degrees. Equilateral triangle. So this remaining angle will be 360 minus 60, 300. The major sector angle is 300. And you can see this is the radius. Why? Because center to this one is this is the circumference. This is circumference. You can see it's given. This is 6 here. Radius is 6 centimeters. All right, children. So that's about this one. What about this? What about this one, children? Read the question and tell me.
Ma'am, area of sector OAC minus OBD.
Area of sector OAC minus area of sector OBD. Yeah. What is the radius of the okay, what is the length of OA?
14 centimeters.
OB?
7 centimeters.
7 centimeters. Okay. So area of the sector OAC, this one, area of the sector minus area of the small sector, this one, will give us the area of this region. Correct. So the value of capital R is 14 and small r is 7. You can also find it using the formula which we understood during the introduction of this chapter. Theta by 360 into pi capital R square minus small r square. Theta by 360 into pi capital R square minus small r square. So 40 by 360 into pi capital R square, 14 square minus small r square, 7 square. Both amount to the same thing. Area of the big circle minus area of the big sector OAC minus area of the small sector OBD. Now, I want you to tell me the equation in words as to how to find the area of the shaded region, and also if the whole figure, the entire figure was shaded. I want both the answers. If the entire figure, the whole thing was shaded, and also for this region.
Area of square minus area
Of square minus sector Area of square minus area of 4 quadrants of circle.
Yeah, area of the square, area of square ABCD minus the area of the 4 quadrants. Minus the area of the 4 quadrants will give us the area of the shaded region. Perfect. And it's given that the side of the square is 14 centimeters. So what's the radius of each circle? What is the radius of each circle?
7 centimeter.
7, not 7 by 2. So earlier we came across a situation where it was 7 by 2. Diameter was 7 and radius 7 by 2. So be careful. From here to here is 14 centimeters. So it should be 7. From here to here is 7 and from here to here is 7. Which means the radius of each circle is 7 centimeters. Radius is 7 centimeters. So area of the square 14 into 14 minus the area of minus all right, let me put it this way. So we need to find the area of the 4 sectors or 4 quadrants. 1, 2, 3, 4. 4 quadrants. Quadrants because the angle here is 90 degrees. The sector angle is 90 because it's a square, no? This angle is 90 degrees. So area of this quadrant, the sector angle is 90 degrees because the square and the corner is 90. This is a sector, this is a sector, or this is a quadrant, quadrant, quadrant. We need to find the area of 1 quadrant, multiply by 4 to get the area of the 4 quadrants. Then area of square minus the area of the 4 quadrants will give us the area of the shaded region. Now what if the whole thing was shaded? The whole thing.
Ma'am, area of the 4 circles plus the result obtained after doing this square minus 4 quadrants.
Without using that answer. Without using the earlier answer.
Area of square plus area of 4 into major sectors.
Very good. Area of the square plus area of the 4 major sectors. What is the sector angle?
270.
270. Yes. So this one is a major sector. This one, see this one, this one. This one is a major sector because this is 90 degrees. This one is a sector. See here, radius, radius, and arc, arc. Yeah. So radius, radius. All right, and this is the arc. This is the major arc. So this one is a sector. This region is a sector whose angle is 270. This one is 90. This is 90. 360 minus 90, 270. This one is 270. So area of square, area of the square, 14 into 14, 196 centimeters square, plus the area of the 4 major sectors. The area of each major sector will be 270 by 360 into pi r square, where radius is 7 centimeters. So multiply that answer by 4. So you will get for all the 4 sectors plus the area of the square will give us the area of the full region if the entire thing was shaded. Write down, children. I want to say something. Please write down this in your book. So sometimes the figure is not provided. Sometimes the figure is not provided. The question will be in words and it will go like this. 4 congruent circles. Please make a note of this. 4 congruent circles are placed in such a way that, because imagine you have the coins, 4 coins. You can place 4 coins, 4 identical coins if you have. Of course, coins are not circles. I'm just telling you, they're circular, right? So supposing you have 4 identical coins, 4 identical coins, you can place them in so many ways. You can just put one next to the other and, all the 4 in a row kind of. So how will the question be for if the coins are arranged like this or the circles are arranged like this? 4 congruent circles are placed in such a way that 4 congruent circles are placed in such a way that each circle touches 2 other circles. That's all. Just want to tell you about the words that mean the circles are placed like this. 4 congruent circles are placed in such a way that each circle touches 2 other circles. Each circle touches 2 other circles. So see in this figure, each circle touches 2 other circles. If you take up any one circle, you can see that it touches 2 other circles. Yeah, which means this is the figure. So sometimes the figure is not given, it's in words, and you need to understand from these words, you need to understand that the coins or the congruent triangles are placed like this. I want you all to work the 10th one because it's similar to this. The idea here. Please work the 10th one, children. I want you all to work the 10th one, read the question, read the information. The figure is given alongside. So what's the status? Has anyone finished? Okay.
Ma'am,
Yeah.
1620.5.
1620.5. All right. So first, with the area of the equilateral triangle, you equated this number 1720.5 to what? That number is equal to
Root 3 by 4 a square.
yeah, so root 3 by 4 a square. And look at the important information given there. The value of root 3 is 1.73205. You need to use that. So children, if you didn't notice that, if you didn't notice this, please, you have to rework. It's given that root 3 is 1.73205. So this one divided by 4 into side square. Root 3, this one divided by 4 into side square is equal to this number. So what is side square? What is a square? What is a square?
2500.
Ma'am, 200 centimeter.
No, my question, what is a square?
200.
See children, root 3 by 4 into side square is equal to that number. I'm asking you, what is side square?
40,000.
40,000, huh? 40,000, I heard 40. Okay, 40,000. So side is equal to
200.
200. Square root of 40,000, which is 200 centimeters. Root 3 by 4. The value given there for root 3 by 4 into side square is equal to the given area. On working that, you get side square is equal to 40,000. Shift the decimal places. You will get 10,000. 10,000 into 4. 40,000 is the area. Is side square. So the side is equal to square root of 40,000, which is 200. So we found the side. We found the side of the equilateral triangle. Equilateral triangle. Now, why did we find that? We need to find the radius of the circle. And it's given that the circle is drawn with the radius equal to half the length of the side. That's why we found the side now. We found the side because only when we know the side of the triangle can we find the radius. Radius is equal to half the length of the side. See, radius is equal to half the length of the side of the triangle. So we found the side of the triangle. We found the side of the triangle 200. Half the length 200 by 200. The radius of each circle is 100 centimeters. The radius of each circle is 100 centimeters. So step 1 is we need to take up this value. This one is equal to root 3 by 4 into side square. On working that, you will get side square is 40,000. Side is equal to square root of 40,000, which is 200. The side of the equilateral triangle, each side of the equilateral triangle is 200 centimeters. It's given that the radius of the circle is half the length of the side. 200 by 2, 100 centimeters. Now what? In fact, you know the area of the triangle itself. You know the side of the triangle. In fact, you know its area directly. And you also now found the radius of each circle. That's all. You have only these two. You have a triangle, you have circles, you know the radii. Now the question is find the area of the shaded region. What's the area of the shaded? Meaning, how do you find the area of the shaded region, children? It's the area of the
Area of triangle minus area of
3 minus sector.
very good, very good. What is the angle in each sector?
60 degree, ma'am.
Yeah, 60 degrees. Angle in each sector is 60 degrees because the triangle is an equilateral triangle. So this angle is 60 degrees, this angle is 60 degrees, this angle is 60 degrees. This one is a sector, children, because from here to here radius. This is radius and this is an arc. This is sector. 60 by 360. Theta by 360. 60 by 360 into pi r square. R is 100. R is 100. Pi is 3.14. Pi is 3.14. So area of one sector is 60 by 360 into pi r square. Multiply that by 3 to get the area of all the three sectors. To get the area of all the three sectors. That one into 3. So now the area of the triangle is given to you. From that, take away the area of the three sectors to get the area of the shaded region. What if the whole thing is shaded? What if the whole thing is shaded? How do you find the area of the entire thing? Are we there, children? Am I audible, children?
Ma'am, area of the triangle plus area of the three major sector.
Yeah, what is this angle in each sector, each major sector?
300, ma'am.
300, ma'am.
300. Correct, 300. So the area of the entire figure, meaning if the entire thing was shaded, then you can compute the area like this. Area of the triangle. Area of the triangle will include this also. When you find the area of the triangle, that includes this area also. So area of the triangle plus the area of the three major sectors. Three major sectors. The area of the three major sectors plus the area of the triangle. Plus the area of the triangle. Triangle includes all this area. All this area. All this area. So area of triangle plus the area of the three major sectors. Sector angle is 300 minus 60. Sorry, 360 minus 60. I've been saying the same thing. 360 minus 60 degrees, 300. The major sector angle is 300. And now I want you to do the, which one is this? 13th and 14th one. Please try 13 and 14. 13 and 14. These two figures.
Ma'am, for 13th question, the answer is 228.5.
Can we see the answer for the 13th one?
Ma'am, for 13th one, 228.5.
228.5. Okay. What's the value of the radius of the okay, that circular, there is a circular region there. What is that circular region? What do you call the circular region? OQP? This circular region OQP is what? Is a
Quadrant, ma'am.
Quadrant.
How do you know it's a quadrant?
Quadrant.
90 degrees.
Yeah,
Because
because
90 degree, ma'am.
yeah, because this is given to be a square. This is given to be a square. So since this is square, this angle is 90 degrees. This is 90 degrees. It's also given here, it's a quadrant. It's given it's a quadrant. Also because it's a square, so this angle is 90 degrees, so this is a quadrant. So the circular region is a quadrant. Now, what is the radius of the quadrant? Is OA the radius of the quadrant?
No, ma'am, it's the diameter.
No, ma'am.
No, ma'am.
Hey, OA is the diameter?
No, ma'am.
No, ma'am.
So, not the diameter, ma'am.
Yeah. Is OA the radius of the quadrant?
No, ma'am.
No. Is OP
No,
the
ma'am.
radius? Okay, is OP the radius?
Yes, ma'am.
Is OC the radius?
No,
No,
ma'am.
ma'am.
Is OQ the radius?
No, ma'am.
Yes, ma'am. Yes, ma'am.
OQ is the radius because from center to a point on the circumference. So OQ and OP are the radii of the quadrant. Name one other radius of the
OB.
quadrant.
OB, ma'am.
OB.
Why is OB the radius? Because from the center to a point on the circumference. B is a point. See here, Q, B, and P lie on the circumference of the circle. You don't see the complete circle here, but this one is a part of a circle. The center of the circle is O, and this arc is a part of that circle. Q, B, and P are the points on the arc. So from the center to Q, OQ radius, OB radius, OP radius. All right, so how did you find OB?
Pythagoras theorem.
By using
Pythagoras
Pythagoras
theorem.
theorem, ma'am.
Give me 1 minute, children. I'm just getting back. 1 minute. Yeah, sorry for that, children. Yeah, getting back. So OB is also the radius of the quadrant. And how do we find the length of the radius? Or how do we find what is OB for the square, children? What is OB for the square? For the quadrant, it is the radius. What is it for the square?
Diagonal, ma'am.
Side, ma'am.
Correct. So OB is the radius of the quadrant. OB is the diagonal of the square. Since we know the side of the square, we know that the side of the square is 20 centimeters. OA is the side of the square, it's 20 centimeters. So since we know OA, the length of the diagonal OB is equal to root 2A, or you can use Pythagoras theorem. Root 2A, the length of the diagonal is root 2A, root 2 into 20, 20 root 2. So 20 root 2 is the length of the diagonal of the square. But why are we finding that? Because that's also the radius of the quadrant. That's also the radius of the quadrant. So we find the diagonal of the square, which is 20 root 2, which is the radius of the quadrant. So the radius of the quadrant is 20 root 2. So now we know the side of the square that's given to us. We know the radius of the quadrant. How do we find the radius of the quadrant? And the area of the quadrant, you know, is 90 by 316 to pi r square. Now, how do you find the area of the shaded region?
Area of quadrant minus area of square.
Area of the quadrant minus the area of the square. All right, the actual answers, I'll share the material. For the actual answers, I'll share the material. So this is the idea. What about this? We have seen a similar one earlier. Tell me using the formula. What's the formula to find the area of a shaded region like this?
Ma'am, area of sector OAB minus area of sector OCD.
Okay, but I said formula, no, some formula we also understood. That's correct.
Theta by 360
Theta
into
by
pi
360
into
to pi r
capital R
square.
square minus
Yeah.
R square.
Both of you are right. Yes, yeah, correct. So theta by 360, 30 by 360 into pi, capital R square minus small r square. Theta is 30 degrees, capital R is 21. You can see, just don't take this value given. Make out, understand if it's capital R. This is a center. This is a point on the radius of the, the outer arc. This is the outer arc. B is a point on the outer arc. From the center to B, radius 21 centimeters. So again, from the center O to this point C, which is on the inner arc. This is the inner arc. C and D are the points on the inner arc. So OC radius, OD radius, small r. OA capital R. OB capital R. So 30 by 360 into pi, capital R square, 21 square minus small r square, 7 square. Yeah, let's just work this and wind up for the class. Wind up the class for today. Try this one, children. This one. 15. First, understand the different parts of the figure. Meaning, now this figure is a combination of some plane figures. So there is a quadrant, there's a semicircle, there's something. So if it's a semicircle, you need the radius. Quadrant, again, radius. They need not have the same radius. The quadrant, the radius of the quadrant may be different from the radius of the semicircle. Yeah, so think of all that and get ready for the questions. All right, I hope you read the question carefully and got all the information from it. Let me read it once. So ABC is a quadrant of a circle. ABC is a quadrant. See it? ABC, ABC, ABC. So at this point, you may have a doubt, like if this is the quadrant for like this is the quadrant, or if this is the quadrant, there may be that doubt. See, because you can see two arcs, you can see two arcs. You may feel, is this portion the quadrant? That is this one radius and this arc, is this the quadrant? Or if radius and this arc. Okay, let's read ahead. ABC is a quadrant. See, ABC is a triangle. This is a triangle, children. ABC, this one is a triangle. ABC is a quadrant, meaning not this triangle, including these circular portions. So, which exactly is a quadrant, we'll read and understand. Now, ABC is a quadrant of a circle of radius 14 centimeters, and a semicircle is drawn with BC as diameter. Semicircle is drawn with BC as diameter. See, this is the diameter BC, and a semicircle. This is a semicircle drawn with BC as diameter. So this is the quadrant ABC. This is the quadrant. This is the arc of the quadrant. This is the arc of the quadrant. This one. This is the quadrant. I'm like going on the boundary of the quadrant. See here, this radius, and this one. This is the quadrant. And BC is clearly the hypotenuse. With the hypotenuse as the diameter, a semicircle is drawn. This semicircle is drawn. The semicircle is drawn with BC as the diameter. That means half of BC is the radius of the semicircle. So that's what we are interested in. We want to know for any circular region, whether it's a quadrant or a semicircle, for any circular region, we are interested in the radius. So we need to find the radius of the semicircle. This is a semicircle, and it's given that BC is the diameter. How can you find BC? Using Pythagoras theorem. Pythagoras theorem will give you BC, and half of BC is the radius of because BC is the diameter. So half of BC. So somewhere here the center is. The center of the semicircle is the midpoint of the hypotenuse. The midpoint of the hypotenuse is the center of the semicircle. Okay, so semicircle, we got the radius. And for the quadrant, which is the radius AB, AC, because center and B is a point of the circumference. So AB radius of the quadrant, or AC is the radius of the quadrant. All right, so for the quadrant, AB or AC is the radius. And for the semicircle, the same thing is not the radius, because for the semicircle, BC is the diameter. Half of BC is the radius. We need to find that. Now find the area of the shaded region. Tell me the equation and words, children. Now I'm sure you'll find, how to find the radius of the semicircle.
Area of quadrant minus area of semicircle, ma'am.
Area of the quadrant.
Ma'am, area of the
triangle.
Area of the minor segment.
No. Second, Arnav spoke. Yeah, Arnav, please complete. What was that?
Ma'am, area of the semicircle minus area of the minor segment.
Okay, let's see if that's right. Yeah, I heard somebody else.
Ma'am, area of the triangle plus the area of the semicircle minus the area of the quadrant.
Yeah, that's also correct. Yeah, Arnav was also right. So Parkavi says area of the triangle plus the area of the semicircle minus the area of the quadrant. You're right, Parkavi. Arnav was also right. So see here, Parkavi says area of the triangle. Okay, this is the area of the triangle. Plus the area of the semicircle. So this full thing. Plus the area of the semicircle. Correct. So that will be the area of the full region, as if the entire thing is shaded. area of the triangle plus the area of the semicircle will give the area of this full thing, this entire figure. Now from that, if we take away the area of the quadrant, this one is a quadrant. If you take away the area of the quadrant, you will be left with the area of the shaded region. That can be one way of finding out. Or like Arnav said, area of the semicircle minus the area of this segment, That's also right. Area of the semicircle minus the area of the segment, will give you the area of the shaded region. Both the approaches are correct. Both are correct. Here the important thing is to use the radius carefully. Radius of the quadrant and radius of semicircle carefully. They are both different values. So how do we find the area of this segment alone? It's area of this quadrant. It's area of the quadrant. So this quadrant minus area of the triangle. Area of the quadrant minus area of the triangle will give us the area of the segment. And then the area of the semicircle minus the area of the segment will give us the area of the shaded region. Yeah, good. We have time for one more. Let us wind up with this one. Look at this, children, this figure. I just want the idea in words.
Ma'am, area of semicircle minus the area of two triangles, ma'am.
No, the shaded region is the circle. The circle is shaded and these two portions.
Yes, ma'am. For this side, area of semicircle minus the area of two semicircles, ma'am.
Two triangles, you said.
Ma'am, for that side, ma'am. For this side, ma'am.
Okay.
Now I'm telling for left side, ma'am. Ma'am, for right side, area of semicircle minus area of the two triangles, ma'am.
Okay.
For left side, area of semicircle minus the area of two semicircles or one circle.
No, I'm scared for the left side. I'm scared you're wrong.
Ma'am, for left side, we can just find the area of the circle, ma'am.
Yeah, because the circle is completely shaded. So here on the left side, as you're mentioning, so it's just the area of the circle. Area of the circle. Can somebody tell me a different way of finding the area of the shaded region here?
Ma'am, area of the sector minus the triangle.
Area of minus sector minus area of.
Area of, no, for this one, this portion. This and this.
Ma'am, area of sector.
Area of circle plus area of semicircle minus area of triangle.
Yeah, who was that? Semicircle minus triangle?
Ma'am, Priya, ma'am.
Yeah, Priya, that's right. So area of semicircle, see here, this one is a semicircle. Area of semicircle minus the area of this one triangle. minus the area of this one triangle. Area of the semicircle. See, this is a semicircle. Area of the semicircle minus the area of the triangle will give us the area of the shaded regions here. Plus the area of the circle will give us the area of the region shaded totally. On this side, area of the semicircle minus the area of the triangle. This you can regard this as one triangle. Area of the semicircle minus the area of this triangle. This one triangle will give us the area of the shaded region here. Then plus the area of the circle. Okay, now answer these questions. What is the radius? What is the radius of the big circle? There are two circles, so that big circle.
7.
Ma'am, 7/2. Ma'am, 7/2.
Children, radius of the big
7,
circle.
ma'am.
7.
7.
OA is 7. OA is the radius 7. The radius of the big circle is 7. And you know how to find the area of the semicircle. Pi r square by 2. Pi r square by 2 or half pi r square. Then how do we find the area of the triangle ABC?
Half base into
Half AB.
Half into base into height.
Half base into
14
height.
into 7.
Correct. Half 14 into
7.
7. Half base into height. Half base 14 because AB is 14. Diameter 14. Half base 14 into height. The 7. AB is the base, OC is the height. So now this difference will give us the area of the shaded region here. Plus the area of this circle. What's the radius of this circle? What is the radius?
7. 7.
7/2, ma'am.
7/2. We don't know where the center lies, meaning it's not marked, but we know its diameter is OD. We know that the diameter of this circle is OD. And since OA is 7, OD is also 7. Since OA is 7, we know that OD is also 7. So what is OD? It's a diameter. So the radius of the circle is 7/2. This is 7. From here to here is 7. So this one is also 7. Diameter is 7. Radius is 7/2. So that's where we have to be careful in taking the values. So here for the big circle, the radius is 7. And for the small circle, the diameter is 7. Radius is 7/2. So that's it, children. So you have to find the area of the semicircle, subtract the area of the triangle to get the area of these two regions. And to that add the area of the circle to find the area of the shaded region. All right, children, that's it for today's session. If you have any questions, please stay back, else you may leave the meeting. Thank you.